Okay, welcome to this video, Unit 3, Lesson 2. We're going to talk about reflections. So there's an informal definition and a formal definition of a reflection, and you'll be expected to know both. The informal definition is that a reflection is a transformation that maps pre-image points to image points by flipping them over a line. So it's a type of transformation. In this unit, we will be learning all the transformations. But the pre-image is, of course, here the image A, B, C, D that does not have the primes on it. And the image is A prime, B prime, C prime, D prime. It's flipped over the line. So if we were to fold it along that line of reflection, we would definitely see that all the points match up. And remember, the pre-image can be XY points and the image is XY points. So the domain is not just X's, it's the XY points if they're on the coordinate plane. The formal definition of a reflection is that it's a function, again, that maps the pre-image A to its image in such a way that one of two things will happen. If the point is on the line of reflection, then the point is its own image. So here C is on the line of reflection. So that means when we are drawing the image of C, it is also going to be, sorry, this is going to take a second, on the line of reflection. So C will equal C prime. If a point is not on the line of reflection, then the line of reflection is a perpendicular bisector of the segment created by the preimage and image point. So that means point B's image on the other side, B prime, is created in such a way that this line of reflection right here, which we're calling line F, is a perpendicular bisector of that segment that connects B to B prime. It's perpendicular bisector. And then A would be the same distance on the other side. So I'm eyeballing it here. That would be A prime. And the line of reflection, which we sometimes abbreviate LOR, is a perpendicular bisector of the segment AA prime. And now that I have reflected each point, I can connect them to see the reflected shape. This is what we call sketching a reflection. You can also use patty paper, tracing paper, or a mirror, which we did in class, but I can't really demonstrate that on here so well. All right, now let's talk about reflections in the coordinate plane. In class, we did a little discovery, so I'm just going to summarize those rules here. All right, so if we are going to reflect in the x-axis, we learned that like for the point like 2, 3, if we flip it over the x-axis, it ends up at 2, -3. So that means xy goes to x, the opposite of y. So that's the rule for reflecting in the x-axis. If you want to reflect in the y-axis and you flip it, it's 2 away from the line. So it goes 2 on the other side to -2, 3. So the x-coordinate changes sign, but the y-coordinate stays the same. All right, now let's talk about flipping the point 2, 3 over the line y equals x. The line y equals x is a line that goes y equals 1x plus 0. So it has a y-intercept of 0 and then up 1 over 1, up 1 over 1 to get that line graphed. So it would look like this. And if we wanted to reflect the point 2, 3 over that line, it's half a diagonal away, so we go half a diagonal on the other side. That becomes 3, 2. So when you reflect something over the line y equals x, then it basically just reverses the coordinates. So x, y becomes y, x. And then the last line that you have to know how to reflect a point over is the line y equals -x, which has a y-intercept of 0, and the slope is down 1, right 1. So it looks something like that. So there's the line y equals negative x. If I wanted to reflect the point 2 comma 3 again, I can see to get to the line in a perpendicular way, I would have to go 1 diagonal, 2 diagonal, and half a diagonal. So half a diagonal, 1 diagonal, 2 diagonal. It would end up right here. 2 comma 3 would end up at negative 3 comma negative 2. So the x and y switch places and switch signs. So that's going to be negative y, negative x. So those are our general transformation rules for those. So let's say I have a triangle at, let's see, at 2 comma 2, that'll be point A. 5 comma or 0 comma 5, that'll be point B. So A is at 2 2, B is at 0 5, and C is at 4 9. So this is going to be our pre-image triangle. This is the kind of problems you might have to do on quizzes, tests, whatever, or as part of creating a design. And let's say I wanted to reflect it over the line y equals x. So that means I'm going to reflect it over this line, y equals x. Sometimes I'll just ask you things like, what quadrant is it in? Or, that kind of thing, and not have you actually do the transformation. But here we'll do it. All right, so if I reflect it over that line, then I'm going to be using the reflection over the line y equals x. I'm going to be switching the coordinates. So a 2 comma 2 is still going to be 2 comma 2 because it's on the line of reflection. So it is its own image, just like our rule from above said. If it's 0 5, it's going to be 5 0 for b prime. And then C prime, you switch the coordinates, it's 9 comma 4. So 9 comma 1, 2, 3, 4. There's C prime. I can connect it and see the final shape now. And it's a very nice reflection over that line. Okay, now let's write our fancy notation. Generally speaking, we have the type of transformation you're doing, which is reflection. Then you're going to write down how you're going to do it. So you're going to have the line of reflection be a subscript. Then you're going to have the pre-image, and it maps to the image. So for our first reflection in the x-axis, if we reflect, the x-axis is the line y equals 0, a horizontal line. So it could say x-axis as a subscript, or it could say y equals 0. Maps a point xy to a point x, the opposite of y. And we're just going to write that notation for the other ones. Last one. Okay, so there's our reflection rules. All right, now let's talk about how to construct a reflection. When we are constructing a reflection, we are basically going to construct a perpendicular from a point not on a line. One of our constructions from our first unit. So like if I want to reflect the 3 vertices, I'll do A first. From A, we draw an arc that crosses both sides of the line. And we get 2 points here for which A would be on the perpendicular bisector. Then from those 2 points, if I take that distance from A to S, and then I come over here and I make an arc from S, and then I make an arc from R, where they intersect will be A prime, because I'm using that same distance. I'm going to show you how to do that. I found this piece of software that I'm not great at using, but I'm going to give it a whirl. All right, so here we go. I am going to put my compass at point A. Oops, right there. Okay, and I am going to make arcs that cross. I think I'm going to make this compass a little bit more narrow. Make arcs that will cross both sides of the line at 2 points. So I'm going to lock this. We'll do this first construction in red. So here we go. There's 2 points. Okay, great. I got that now. And then I'm going to measure from A to the first point. Okay, that is the distance from A to the line. I want to go the same distance on the other side so I can find A prime. So I'm going to make an arc here. And then from this point, I'm going to make the same arc. And where those two arcs intersect, that's going to be A prime right there. That's the first point. All right, now I'm going to complete this construction again from point B. We'll change the color so we can see better. I went across the line so that I can get 2 points by making an arc that crosses both sides of the line. So okay, there's 1 point, there's the other one. I'm going to measure from B to that point, which is what I have right here. It's jumping around on me. All right, so now I'm going to, I got that point, it's set. There's one arc. I'm going to move it up here and do the other one. I just have to make sure the compass doesn't go above it. Oh, well, I got it. So where that one intersects, right here, that's point B prime. And last but not least, I'm going to do C prime. All right, I'll do this one a different color. I need to go to the other side of the line so that I can make it cross twice. Once there, down here. Okay, so I have from C to that point. I'm going to move it. Oops, I did not mean to do that. There we go. Lock it. I want this to be right here. Right there. All right, let's make our arcs on that last one. There's here. And I'll make the arc from this point. Fun, fun, fun. And now we're going to have this point is going to be C prime. So I can now construct my triangle. Turn that off. I don't want that on there. There's my reflection. So we have B prime, C prime, and A prime. So there's my construction of my reflection. I had to do a perpendicular from a point not on a line 3 times. So that's the end of that one. I also wanted to show you this construction here that we did a minute ago that we did in the coordinate plane. I do have it on GeoGebra set up to show you. I wanted to show you how to do a construction on GeoGebra. So if you want to construct it, I've pre-set up the picture and the line of reflection y equals x. We go down to transform, reflect about a line. It says select the object to reflect, then the line of reflection. So I'm going to select the entire triangle. It's okay if I select the line of reflection because it'll just map onto itself. And then I'm going to click on the line, and there's your nice little reflection. And you can see it's dynamic. It maintains its cohesiveness. If I go up here and click move, if I move point C, its reflection point moves. I can even move it to the other side of the line. Okay, I can move point B. I can move point A. But I cannot move the image points because they're based on where the pre-image was. All right, let's talk about a couple of final properties of reflections. What properties do reflections preserve? Well, they do preserve, and we have a nice little reflection of what looks like the letter P over here. Okay, they preserve angle measure. Yes, they do preserve that because if an angle here, say, is 90 degrees, this angle here will be 90 degrees. So the shape is the same size, the same shape, so it has the same angle measures. It has the same segment lengths. The length of AC is going to be the same as A prime C prime. They preserve collinearity. Point G here is collinear with A and B. G prime is collinear with A prime and B prime. So they are preserved. Betweenness, yes, G is between A prime, B prime, just like it was between A and B. The one thing that is not preserved is orientation. You can see if you look at the figure that this letter P here is orientated pointing to the right, but here it's pointing to the left. Now, there's a more concrete way to test that I want to show you that has to do with naming the figure. And so I'm just going to use this figure to name it. So let's say I was to start at point A here and go around clockwise and name these 4 points on this little square looking thing. It would be A, C, F, G. Okay. If I started at A on this one and also went around clockwise, I would get A, G, E. Oh, I'm sorry. That's not an E. That's an F. A, G, F, C with the primes. See how they are not in the same order? That is a change in orientation. If you start with a point, go around clockwise, and start with the same one and go around clockwise, and you get them in a different order, no matter where the first one is, that is reversed orientation. So a reflection reverses orientation. Okay, that's why when you look in the mirror and you're wearing a t-shirt with letters on it, they look flipped around the wrong way. All right, the last thing is to construct a line of reflection given an image like this one. We have a figure that has been reflected, but we do not have the line of reflection constructed. So what you do is you're going to do the perpendicular bisectors for 2 segments because the endpoints of those segments are on the perpendicular bisector being the line of reflection. So what I'll do is I will connect B to B prime, and I'm going to construct the perpendicular bisector of that in order to find the middle. Now, I can't get this picture onto my compass tool, so I will kind of eyeball it, and I'll say, okay, from B, I'm going to open my compass more than halfway across and make a half circle. From B prime, I will do the same thing. And where those 2 half circles intersect is the midpoint of BB prime. You do the same thing for another point. I'm going to make a half circle from D, and with the same radius, a half circle from D prime. Where those intersect goes through the midpoint. And then finally, to get your line of reflection, you will connect those 2 midpoints, and that gives you your line of reflection. Only it'll look much nicer with a real compass. Now, if you're sketching it, you can just eyeball the midpoints and then connect them. So we said a orientation of a figure under transformation can be the same or reversed. We talked about the clockwise thing. So a reflection is the only transformation that reverses orientation. A little side picture I have is that if you double reflect the pre-image of a triangle, will the final image be same or reversed? So let's say I have a little right triangle here, okay? And I reflect it over this line, triangle ABC. So if I just want to sketch the reflection, it would look something like this. Point A would still be the right angle. This would be C prime, and then up here would be B prime. But then let's say I double reflect it. I reflect it again over another line here, okay? So it ends up like this. A double prime, B double prime, C double prime. See how going from here to here, it reverses the image back. So whenever you reflect it an odd number of times, its image is reversed. But if you reflect it at an even, it switches back to be the same as what it was. So the final image will be the same if you do it twice. All right, that is the end of this lesson on reflections. Okay, our next lesson, if you join us for that one, will be, I think it's rotations. It'll be rotations or translations. And this is going to be a very short unit, so we're going to be moving along just fine.